Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of Cartesian equation of plane. So as per the problem, determine the Cartesian equation of the plane that passes through the points 1, 4, 5 and 3, 2, 1 and is perpendicular to the plane 2x minus y plus z minus 1 equals 0. The first step is to draw a diagram for this problem to understand what's given and what we need to find. Let's start by drawing a plane. Let's assume this is the plane for which we have to find the equation, and the 2 points 1, 4, 5 and 3, 2, 1 lie on this plane, and this plane is perpendicular to the given plane 2x minus y plus z minus 1 equals 0. Next, we should write the general equation of a plane in Cartesian form. In this equation, a, b and c are the coefficients of x, y and z terms. They are also the components of the normal vector for this plane. For the given plane 2x minus y plus z minus 1 equals 0, the normal vector is 2 minus 1, 1. Two is the coefficient of the x term, negative 1 is the coefficient of the y term, and 1 is the coefficient of the z term. We can show the normal vector in this diagram. This normal vector can be considered a direction vector for the plane for which we have to find the equation, because this normal vector will be parallel to that plane, because normal vector is perpendicular to the plane. So as a result, this normal vector will become parallel to the plane for which we have to find the equation. So we can write the first direction vector for our plane as two minus 1, 1. Now we can find the other direction vector for this plane using the 2 points that lie on the plane. And for that, we should subtract the position vectors of those 2 points. Now we can subtract these vectors. So we should subtract their x, y and z components. 3 minus 1 is 2. 2 minus 4 is negative 2. 1 minus 5 is negative 4. This is the second direction vector for our plane. We can see that the two direction vectors are not scalar multiples of each other. So that means they are not collinear vectors. We can use these two direction vectors to find the normal vector for our plane. We should do the cross product for these two direction vectors, because cross product of two vectors gives us a vector that's perpendicular to the two vectors for which we are doing the cross product. Now we can do the cross product by stacking the y, z, x and y components of these two vectors. For the first vector, the y component is -1, z component is 1, x component is 2, and y component is -1. For the other vector, the y component is -2, z component is -4, x component is 2, y component is -2. Now we can find the x component of the cross product vector by cross multiplying the y and z components. So we start with -1 times -4 minus -2 times 1. I get x equals 6. Now we can find the y component, and we should cross multiply the z and x components. We start with 1 times 2 minus -4 times 2. I get y equals 10. Now we can find the z component. We should cross multiply the x and y components. We start with 2 times -2 minus 2 times -1. I get z equals -2. That means the normal vector for our plane is 6, 10, -2. Now we can sub in the components of this normal vector into the general equation of the plane in Cartesian form. A is equal to 6, B is 10, and C is -2. Next, we have to find the value of D, and for that we can use one of the two given points. I'll use the point 1, 4, 5. So we should sub in x as 1, y as 4, and z as 5 in this equation, and then solve for D. We can isolate D by subtracting 36 from both sides. I get D equals -36. Now we can sub in the value of D in this equation. So we get we can reduce this equation by dividing each term by 2. So this should be the final answer for the Cartesian equation of the plane. These are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.